All right, so in this video, we're going to talk about work. Work is the way that you transfer energy to an object. And the equation for it is that work equals force times distance. So what this means is if I have, say, a box and I exert a force on it, let's say 20 newtons, and in doing so, I push this box along the ground and it moves forward, say, 3 meters. So I have pushed the box with a force of 20 newtons for a distance of 3 meters. My work done will be 20 newtons times 3 meters equals 60 newton meters, or 60 joules, as it were. And so what we notice about this is the more force you push with, the more energy you'll transfer, and the longer you push it for, the more energy you'll transfer. Basically, this box is going to gain this much energy in one fashion or another. Now, one thing about work is the force has to be in the same direction as the distance. So in other words, I push this to the right and the box moved to the right, therefore I am doing work. If I were pushing up and the box moves to the right, that would not be doing work. It has to be in the same direction, or I guess it could be in the opposite direction. So if you had like a car that was rolling this way and a bunch of people got in front of it, not a good idea probably. The car was moving this way and they were pushing it to the left. That would be doing negative work on the car, basically slowing the car down. That would be considered work. And there are situations where you could do a force at, say, an angle. This video isn't getting into any of that. We're just really going with a very simple definition that work is the force times the distance as long as they are in the same direction. So let's look at some problems. So here I'm trying to calculate how much work is done. I have a box that is 4 kilograms, and I'm pushing it with a force of 20 newtons, a distance of 5 meters. So the direction that it's moving is the same direction I'm pushing it. So I'm doing work, 20 newtons times 5 meters, I get 100 joules. Now notice that was not used at all in this problem was the mass. It doesn't matter when I calculate the work. If this box were more massive, I would still be doing 100 joules of work on it. It's just if this box were much more massive, after I pushed it this far, this box is going to have a certain speed. A more massive box would be moving more slowly because it has the same amount of energy. So that's a separate calculation later, but the point is the mass is not impacting it. All that matters is the force you exert and the distance over which you do it. So now I'm lifting a box up. It is an 8 kilogram box, and I am trying to pick it up. So whenever you pick up an object, at a minimum, you have to overcome its weight. This has a weight of 80 newtons. We just multiply by 10, which is the value of G on Earth. So I'm going to have to pick it up with a force of 80 newtons. Generally assume you're picking it up at the minimum force unless told otherwise. So I'm lifting with 80 newtons. The box moves up 3 meters. So my work done is simply 80 newtons times 3 meters, or 240 joules when I lift it up. Notice the mass mattered here because the mass affected how much force was needed to pick it up. If I were pushing this across the floor, I wouldn't need this 80. That's only because I'm lifting it. So when you lift something, the weight, the mass matters because it directly impacts the weight. But if you're pushing it across the floor, the mass is not going to really matter when we calculate our work. Now, how much work is done when I lift up an object by 4 meters? So it's a 2 kilogram object. So again, it has a weight of 20 newtons. So to pick it up, I'm going to use 20 newtons, and I'm going to lift it by 4 meters. So my work will be 20 times 4, or 80 joules to pick it up and bring it here. And then I'm going to carry it across the room 10 meters. And so when I'm carrying it, I'm still lifting. I still have to exert a force of 20 newtons upward, but I'm moving it sideways. So here the force is in a completely different direction. It's 90 degrees to the movement. This is not going to actually do work. So I do 80 joules during the lifting, but I'm technically doing 0 joules here. Now, if you've ever lifted something and carried it across the room, you know it's not easy. It feels like work, but we're, again, talking about physics work, that definition. And the physics work is 0 because the force is not in the same direction. The main reason it doesn't change is when you do work, you give an object energy. Well, this box still has the same potential energy. It's still the same height above the ground. It's not getting any faster. It has no more kinetic energy. So there's no added energy to it, so no work is done. So the total work would be the 80 joules in picking it up, the 0 joules in walking it across the room, for 80 joules total. All right, here I am pushing a box across the room. It's a 6 kilogram box. I'm doing 90 joules of work, and this problem forgot to mention that we have a distance. Let's say it's 15 meters across the room. That is needed information. So if I push it, say 15 meters across the room, my work done is 90. So work, again, equals force times distance. My force is unknown, but my distance is. I'll divide each side by 15. And so my force is 6 newtons. So if I exert 6 newtons for 15 meters, if I multiply those, I get 90 joules. So that checks out. Here I'm picking up a box. The box is 4 kilograms, which means it has a weight of 40 newtons, which means I'm picking it up with a force of 40 newtons. I want to know how far I lift it. And so I know my work done is 100 joules. My force is 40 because that's how much it takes to pick up. So work equals force times distance. I have 100 equals 40 times d. If I divide each side by 40, the distance will be 2.5 meters. So effectively, I have given this box 100 joules of energy in lifting it 2.5 meters, which checks out if we know about energy. Energy is mgh, potential energy. 4 times 10 times 2.5, this equals 100 joules. So the energy, the work I put into lifting it, all went into the energy of the box, and now the box has gained that much energy. So again, that's work. It's very similar to impulse. Impulse is how you give an object more momentum. Work is how you give an object more energy. There's slightly different equations though, so just pay attention to the units and check all your numbers with that. But until next time, I am Derek Genova. Have a delightful day.